Let's take a look here at example number 1, continued. We want to go ahead and go back to this tax preparation method question where we were given a percentage for each individual category of how individuals may have been filling out their taxes. Remember that this was based on a previous survey. And then we went out and we were wondering, are these values going to be the same now as they were previously? So we observed a bunch of individuals. The problem says here that we took a sample of 300 adults and asked them how they did their taxes. We wrote that down. We also then had what we expected to be the case if these percentages were still correct. So what we want to do now is perform this chi-squared goodness of fit test to test whether the distributions are different than the previous survey. That is what we observed here evidence that these percentages are maybe okay or that they need to be changed? So we'll start right away here by going to our hypotheses. And our hypotheses aren't really any different than what they were in the previous videos. What we'll state here at the beginning is that the percentages for how people prepare their taxes not is, but I'll say are the same as the previous survey claims. That is, we're saying that the percentages for how people prepare their taxes are exactly these percentages. So another way we could state this is that all the previous percentages are correct, right? We're saying those values up there are okay. Now, our H1, remember, is just that at least one of the previous percentages is not correct. Okay? So at least one of them is not correct and maybe needs to be adjusted. So what we can go ahead and take a look at now is the test statistic. It's important for us to note that with the test statistic, we have to go ahead and enter a bunch of different values into the calculator. So when we go ahead and do this, I'm going to go ahead and flip over to my calculator here and show you how we would go about actually completing this. So I'm going to flip to my calculator. I'm going to go to the Stat button. And when I click on the Stat button, I want to go to Edit. And this is taking me to my lists, and I'm going to try to go ahead and enter all of these different values into the calculator one at a time, just like we had them in the table. So I have all my observes in the first column, and then everything that I expect is going to be in the second column. Okay. Once I have this written down, I can go ahead and start to perform my different checks. Okay, so going back to here, I can see that if I was to write down first the step on evidence, what we just did is we entered data into lists. Okay, great. Now when I do my checks, I'll see that there are 4 checks that I need to do. Those 4 checks are listed on the previous page. You could also find them on the new formula sheet that's going to be for Chapter 10 and 11. In here, I'll just go off of what is stated on the previous page of the notes. So the first check says that I need to make sure that my observed frequencies are gathered from only one sample and that they come from a random sample. Well, here I definitely only did one sample of 300 adults, and it was told that it was random. So here I can kind of just check this off immediately. There's not even really much to write. For check number 2, check number 2 says all expected frequencies are greater than or equal to 1. Well, if I look at my expected frequencies, they're definitely all numbers that are bigger than or the same as 1, so I can check that off as well. Number 3 says no more than 20% of the expected frequencies are less than 5. So my question's going to be, how many of these expected frequencies are less than 5? Okay, well that's pretty easy to see. 0 of these are less than 5, so 0 out of 5 of them are less than 5. As a percentage, that's 0% of them are less than 5. And check 3 says, as long as that percentage isn't over 20, you're okay. So perfect, we're good to go. Number 4 is often the one that seems to be the most tricky to check, only because we sometimes get tripped up by what it asks with sampling without replacement. If I'm sampling without replacement, remember that that means that I'm not going to survey any individual multiple times. I'm not going to survey them and then replace them back into the group of individuals that I'm going to continue to ask questions to. So we want to make sure that each of these observed values here represent unique individuals, that we didn't survey anybody twice. Now, of course, that seems pretty obvious that we would have done that here. So if it's the case that we sampled without replacement, which here we most certainly did, I need to check my 20 times n is less than or equal to capital N. Of course, here that means that I have something like 6,000 is less than or equal to n. So if little n, 300, was a number of people that filled out their taxes, then hopefully capital N, all the people that fill out their taxes, is greater than or equal to 6,000. If we're in the US, I certainly hope that's the case, so I can check that off. And since all the checks are met, I know I can proceed with the test. So I can go ahead here, and I'm going to set up my test statistic value for chi-squared. And I'll get that on the calculator when I start to take a look here at the next step of analyzing the data. So I'm going to go back to my calculator now and begin to run the test. And I'm going to be going to the test menu. When I click on Stat and I scroll over to Tests, I'm actually going to go ahead and scroll up to get to the bottom of my list very quickly. And I should see in here that I have two different tests. I have a chi-squared test and a chi-squared GOF test. I want the GOF because that stands for goodness of fit. Now, some of you might be realizing at this moment, if you're following along with your calculator, that you do not have a chi-squared GOF test. And if that's the case, it's likely because you are working with a TI-83 as opposed to a TI-84. Now don't worry, everything's still fine. I'll show you in another video how you can actually go ahead and still complete this test. But let's go ahead and proceed with the test that we have here. So if I was working with this test, notice that the first thing that the calculator is going to ask me is, what is it that I observed and what is it that I expected? And we already entered these values into lists, so I can just tell the calculator the appropriate lists. Fortunately, mine are already set up like this, so I don't have to change them. The next thing I have is the degrees of freedom. Remember that this is always going to be, for a goodness of fit test, the number of categories that we had minus 1. So if you look back at your table, you can see that we were asking people how they prepared their taxes. And we had 5 different categories: an accountant, by hand, computer software, friend and family, or tax preparation service. So since there were 5 categories, we take away 1, we're left with 4. Once I go to calculate, I should be able to get all the values now that I need. And you'll see right here at the top is my chi-squared value. So I'm going to write that down, 35.1213 if I round. So 35.1213. Down here I'm going to go ahead and I'm going to start to sketch out my nice distribution curve. Remember, my chi-squared curve starts from 0 and goes over. So I have 0 here. And here's a bunch of chi-squared values on this number line. We got a chi-squared value of 35, so that's kind of pretty high. That might be over here somewhere. And again, every one of these tests is always a right-tailed test, always, with no exceptions. And so we're going to be shading over there. And remember that this value here is our p-value. We can even think about the setup. The p-value there is going to be the probability of getting a chi-squared value that is greater than 35.1213. And remember that the calculator even told us this value. I just have to be careful as I write it down. This value is 4.38 blah blah blah, but oh wait, notice it's E-7, so that means I need to have 7 zeros at the start, including the one before the decimal point. So my decimal looks something like 0.000, it's 4 zeros, 5, 6, 7 zeros, and then a 4. If I round that to 4 decimal places, that's roughly 0. So when I compare this with my value of alpha, like we always do on every question with hypothesis tests, I can see that on this question my alpha was given as 1%, and clearly I have a p-value that is lower than my alpha. So it's apparent now that I have a rare sample. And whenever we have rare samples, remember that's good reason to reject H0. So here would be my conclusion. I would state something like, it is rare to get a chi-squared value of 35.1213 if H0 was true. But H0 being true is if the percentages from the previous survey, are all correct. It would be super weird to see what we saw if all of those percentages from the previous survey are still actually correct today. So we have reason to believe that at least one percentage is not correct. Now notice we don't know which of the original percentages we're thinking might not be accurate. Maybe one of them, maybe multiple, maybe all of them. But we're definitely siding on they're definitely not all perfect. Maybe some of them are. Maybe some of these percentages are okay. But we're not confident that all of them are okay. And that's where we're ending our test. Now in a future video, I'll go ahead and take a look at how we can actually try to find this chi-squared value and this p-value if you didn't actually have the nice calculator commands that we used in this video. So if you didn't have that calculator program, make sure you watch the next video to see how I create those values without the use of that fancy program.